All right, well, good morning, everyone. My name is Elizabeth Stark. I am CEO and co-founder of Lightning Labs. We're building layer 2 scalability technology for Bitcoin and other blockchains. And I'm here to talk to you today about why layer 2 matters for the future of the decentralized internet and for blockchains. Let's take a trip down internet history lane. The year is 1995. The proprietary networks like AOL, CompuServe, Prodigy actually controlled the way that people would connect to their networks. But it turned out several years prior, the World Wide Web came out, Tim Berners-Lee came up with it, and it enabled anybody to build on top of it, and it was decentralized. So ultimately, it was the World Wide Web that won out over these proprietary networks. 1995 was a crucial year in the history of the internet. So Time magazine on March 1st, 95, declared welcome to cyberspace. Millions more people were connecting to the internet due to the breadth of what the web could offer. There were lots of animated GIFs. You saw lots of under construction signs. And you also saw Netscape IPO'd this year, and one of the most significant ones of its time. 1995 was also the year Hackers the movie came out. Who here has seen that movie? Great film, right? Great soundtrack. And turns out some friends of mine in New York just 2 years ago did a 20th anniversary party for that film in a warehouse in Brooklyn. One of the actors actually showed up. So then we had this transition to the OOs, the knots, if you will. And we went from the more decentralized web, when lots of people spun up mail servers and ran, their own web servers, to this concept of the cloud, right? And the idea was great. You could then put your data in this ominous place called the cloud, and it was super easy, and you didn't have to store it on your own server. You also saw the advent of walled gardens. So you had, Facebook, Twitter coming alive then, and they were platforms where all the user data was stored in a centralized manner, and they could control things. So they could shut down your account, they could go offline, they could actually potentially censor users, and all your data could potentially be compromised as well. And you had these entities that controlled these walled gardens. But actually, it turned out there really was no cloud, right? As we've learned later on the internet and via various memes, it turns out the cloud was just somebody else's computer. And your data was actually stored on that computer. So as we've learned today about Blockstack, there are many issues that come along with that. So along came 2008. Something major happened in the history of global financial markets. What was it? Yep, so an individual or group of individuals going by the name of Satoshi Nakamoto, this is another guy whose name is Satoshi Nakamoto, different guy, came out with the Bitcoin white paper, peer-to-peer electronic cash system. And essentially what this proposed was the first blockchain. There's been some previous academic research, but really this is the first time in the paper the term chain of blocks was used. And what we had here was this major opportunity. I don't even think many realized it at the time, but when I first heard about Bitcoin in actually 2010, I saw this potential to re-decentralize the internet and to move things in a way back to the more mid-90s decentralization that we had and away from this concept of walled gardens and the central cloud. So when Satoshi first sent his proposal to one of the major mailing lists, it was the first time that this went out, one guy responded. This is the first response to Satoshi. Basically said, this is a very important proposal, we really need something like this, but I don't see how it can possibly scale. Basically, cool story, doesn't scale. So as we've heard earlier from Manib, there's a major challenge in scaling decentralized blockchains. Because the fundamental aspects of these chains, like Bitcoin, is that you have to have global consensus across the network. You have to have a variety of full nodes that are validating the transactions on the network. This is how you solve the double spend problem in tandem with the miners that secure the network. And it turns out, imagine if to send an email, you actually not only had to download every email you'd ever sent, but actually any email that anybody had ever sent. Well, that wouldn't be really efficient now, would it? So we can actually look to the history of the internet and the layers that were built on top of it to look to the future of blockchains. So here we have two different structures of layers of the internet. One is the OSI method, and the other is that of TCP/IP. And they're similar. TCP/IP has fewer layers. But the basic idea is at the lowest core level, you have the physical layer, the network interface. Then you have TCP, transmission control protocol, and IP, internet protocol. And then on top of that, you have a variety of application layers. So you can think HTTP, Telnet, FTP, Gopher, and actually Bitcoin would be one of those as well. And then so much of the innovation in the applications we see today are because of that application layer and because of the architecture that we've seen, where it was not all squashed into one layer. We had the variety of layers that could build on top of each other. So right now, we're basically in 1995 all over again when it comes to blockchains and decentralized technologies. And we have a major opportunity. What blockchains can do is they can serve as the base layer for the decentralized internet. And we can actually have this layer 2 that we're all building, Blockstack, Lightning, things like that, that can use the underlying blockchain as an anchor for data. It can use it to anchor transactions. It can use it to anchor data for domain names. You have Blockstack, as we've all learned about earlier today. You have Lightning, which enables instant high-volume transacting and payments. You have Tumblebit, which is payment channels on top of Bitcoin and potentially other blockchains that enables anonymity. State channels, which can enable off-chain contract state. And part of why this is so important is it minimizes the amount of data you have on the underlying blockchain, and then you can do things off-chain, building on top of the blockchain in a decentralized manner, but it's still anchored to the underlying blockchain. So you have the types of applications on top of layer 2, and then you have developer APIs. And what layer 2 can really be is the application layer for blockchains and for the new decentralized internet. It can be the HTTP for blockchains. So back in 2015, 2 community members and colleagues of mine came up with this paper for the Lightning Network. I actually helped to edit it. And the basic idea was because of this fundamental scalability problem of Bitcoin and other blockchains, things couldn't really scale on-chain to reach all 7 billion people in the world. But what you could do is you could create instant, high-volume, off-chain transactions that still use the underlying blockchain for security. And it turned out you could do this in a peer-to-peer network, so you didn't have to trust an intermediary. So basically, the way the Lightning Network works is you have 2 participants, good old Alice and Bob. How many crypto people have seen that, quite a bit in your classes and so on? And they enter into a 2 out of 2 multi-signature transaction on the blockchain. So you have your initial anchoring transaction that gets you onto the layer 2 Lightning Network. So Alice puts in $10, Bob puts in $10. They now have a $20 what we call payment channel. And Alice and Bob, the blockchain, by the way, only sees this initial transaction. Now they can transact with each other and they can update the state. So they continue to exchange digital signatures. And maybe now Alice has $9 and Bob has 11, and they can go back and forth. Now, this sounds like, well, what happens if Alice might actually just want to steal Bob's coins? Well, it turns out there's a cryptographic proof that revokes the previous state such that if Alice tries to steal Bob's coins, Bob can go back to the blockchain, have a proof that says, actually, Alice just tried to steal my coins, and not only can I get my currency back, I can get all of her funds too as a penalty for trying to steal his coins. Now, another scenario is, well, Bob could just go offline. Maybe Bob is like hanging out in Antarctica, has no internet, and is there for months. And these 2 are connected, and Alice wants her money back. Well, actually, we use time-locked contracts on the blockchain such that even if Bob goes online, all Alice has to do is broadcast the transaction to the blockchain and wait for a timeout period, and she can still get her money back as well. So one of the core tenets of this is you don't have counterparty risk where you have to trust somebody you're transacting with. But actually, it turns out maybe Alice and Bob only pay each other once a year. So it's not very useful for them to transact off-chain, even if it's possible for them to do it, say, thousands or millions of times. But the really cool thing about Lightning is it can chain all of these transactions together. So here you have, Alice wants to pay Erin, and then poor old Fred over there is just hanging out and is not in this transaction. But actually, the way this is cryptographically designed is that, from Alice to Bob to Carol, Bob can only receive the funds if and only if he's already forwarded them onward, such that you actually cannot compromise funds when you have this multi-chain transaction. We call this multi-hop in Lightning. And the analogy is the way that packets can flow on the internet through a variety of servers, actually payments can flow on Lightning in this manner. So Lightning at its core is actually a smart contracting system built initially on top of Bitcoin. It's not one that can do everything. It's a much more limited contracting system. But these timeouts that enable everyone to get their money back and not have counterparty risk are a core tenet of this type of contract. So fundamentally, the way that Lightning works is it uses a blockchain as an arbiter. The blockchain is a court. And actually, kind of like the way that you have contracts in real life, not every contract goes to court. Well, in this case, you could transact thousands, maybe even millions of times, and then you could settle to the underlying blockchain. And then if somebody tries to cheat you or if they go away, you know that the blockchain is always there to secure your transaction. Now, it means that the underlying blockchain needs to be secure, but we know that Bitcoin right now is the most secure public decentralized chain. So fundamentally, the blockchain functions as a global decentralized judge that cannot be bribed. It can't be bribed because everything is predetermined in the smart contracts, such that the blockchain knows exactly how to interpret it. So it turns out Lightning cannot just work for the Bitcoin blockchain, but it can work for other blockchains, and it can also work between chains. So here we have Alice and Bob, and then there's some intermediate node. Alice is Bitcoin, and Bob is Litecoin, and they want to transact and go between the two. And then intermediate node can have liquidity in both currencies. And then using the same method that enabled when we talked about how Bob can only receive the funds if and only if, Bob can only send the funds if and only if he's already received them, you can do this across currencies, such that you can have decentralized, we call them cross-chain atomic swaps between assets. And this uses the same technology as Lightning. We call this multi-chain in our software. So at Lightning Labs, we build what's called the Lightning Network Daemon. Our code is all online, github.com/lightningnetwork/LND. And we recently released support not only for Bitcoin, but for Litecoin, so we now have 2 chains. Yeah, github.com/lightningnetwork/LND. And it turned out that segregated witness, a key change to various protocols that fix what's called malleability, had activated on Litecoin. So this was a big opportunity to bring Lightning to Litecoin. And then it also just, last week, finally hit the major mark to activate later next month on Bitcoin, which is a huge milestone for us in terms of building Lightning and enabling instant high volume and low fee off-chain transactions. So I talked a bit about how layer 2 can be the application layer. And actually, one really cool thing is we've seen a lot of developers, before we actually put any documentation up, building applications on Lightning. Because it turns out a lot of users don't want to have to wait for the 10 minutes it takes to confirm on Bitcoin, or even say 2.5 minutes it takes to confirm a transaction on Litecoin. And you can do all sorts of really interesting things where you could pay 1 cent, 1,000 times a minute, or even 1,000,000 times a minute. And people often ask, well, why would you need something like 1,000,000 transactions, say, per second? Visa, by contrast, can do 40 to 60,000, and Bitcoin today can do about 5, and it'll soon be maybe 10. And the reason is, it may not just be humans transacting, it'll probably also be machines. And you can do all sorts of interesting things with high volume transacting. Also, when you have the ability to execute given a certain condition, which we'll soon do on Lightning. So this leads us to the idea of, well, we've talked a lot about what layer 2 can do, but actually we're just in the very early stages now of figuring out exactly what layer 3 can be. But the idea is you can have an additional layer that you can build upon that can go back to the layer 2, that can go back to the layer 1. It can do things like smart contracting, algorithmic trading, and really interesting things. So check out dev.lightning.community. We just put up some developer resources. We're at Lightning on Twitter, and look forward to talking to you all today more about what Lightning can do and why layer 2 is crucial to bringing the blockchain to the world. Thanks so much.